Hello guys, so welcome back to another video of AJ classes. So today the question is to prove that if p square is even, then p is even by the method of contrapositive. We know that what is contrapositive. If we have given p conditional to q, then we have to if we are able to show that negation of q conditional to p is true, then we can prove that p conditional to q is true. That means what? Here what is given? We have to prove that if p square is even, this implies that p is even. We have to prove this one. If p square is even, then p is even. That is, in method of contrapositive, we have to prove that in the method of contrapositive that if p is not even, this implies that p square is not even. So this is the opposite. We will take the opposite of this one and find out the opposite of this one. The p square is not even. So in the method of contrapositive, you have to show that if p is not even, then p square is not even, and if we prove this one, then we can indirectly prove that if p square is even, then p is even. So for to prove it, let p is not even. So we know that if you take p is not even, we know that this implies what is p? P is odd. If p is not even, that means the p is a odd number. And let we take this p is equal to 2k plus 1. We know that the odd numbers are the one more than the even numbers, that any multiple of the 2 and plus 1, that will be a odd number, and where k is an integer. Where k is an integer, we take p is equal to 2k plus 1. So now we will take the p square is equal to 2k plus 1's whole square. So we know that from here that p square is equal to 2k plus 1, and if you put the formula a plus b whole square, a square plus b square plus 2ab, this will be 4k square plus 4k plus 1. From here you can take that, this will take common here 2, this will be 2k square plus 2k plus 1. From here you know that this is a multiple of 2. Let we take this is as m, 2m plus 1, where m is equal to 2k square plus 2k. So we know that if you have to prove this is odd, that means you will add plus 1 with a multiple of 2. So this is a multiple of 2 and this is 1. So here this is p square. So from here you can find out that what we find that p square is equal to 2m plus 1, and this implies that from here you can find out that p square is odd. If p square is odd, this implies that we can find out that p is also or not. If p square is odd, we know that p is odd, or that p is odd or not even. So from here we can prove that if we prove this one, this is directly implies that if p square is even, then p is also even. This is the proof of that if p square is even, p is even by the method of contrapositive. Like the video and subscribe the channel for the latest updates.